Group 6. When you think about strength, being strong, what do you think about? What comes to mind? Think about that for a second. Perhaps Superman comes to mind, strong guy. The Hulk, maybe, very strong. Or even maybe 4 times Mr. Olympia, Phil Heath. These are very strong individuals, but I'm willing to bet you that you never ever think of ants as being strong. Well, at least not until today. We're about to change that. Because here comes this guy, the Azteca andrea. It's a scientific name, aka the Velcro ants. At first glance, they appear normal, like your average ants that you would find in the backyard. Small. Those guys are highly predatory. They feed on other insects. They're ambush predators. They ambush their prey and capture them. They live on trees. They like to build carton nests outside on tree branches, and they are almost exclusively found in the tropics of South America. Now, what makes this guy special? You can guess it. Their strength. Those guys have super ant strength is the proper term there. As you can see with our pictures, those guys are strong. Now, let me put in perspective. Those guys are able to capture, the Azteca andrea that is, are able to capture prey that are up to almost 14,000 times their body weights. That is equivalent to a house cat holding a humpback whale without getting crushed. See this guy holding this guy. You see how small that human looked next to the houseback whale? So think about him holding him. It's not gonna happen. That's the strength of the Azteca andrea put in perspective. Now, this is a demonstration of the Azteca ants actually capturing a moth and holding on to a moth many times their body sizes. And as you can see, most of the moth's body is hanging off the leaf and it's not falling off. In fact, it's not going anywhere. Once those guys have a jaw on it, it's staying there. And this is another demonstration of a single. Even though there's a couple ants in that section, in fact, it's this one where the L was printing that's actually holding on to a 4.11 gram coins. Remember, those guys are only about a couple milligrams in weight. So that's pretty impressive. That's about 6,000 times this guy's body weight, and he's holding on with no problem. Now, the question is how? How is it done? How's that possible? How are they doing this? Now, those guys have evolved special hook-like claws. This is a scanning electron micrograph of the hook of a worker ants. What they do is those hook, they're able to hook them into the loops of the underside of trees. Some trees have fibrous underside, so they use that claws and kind of hook it in those loops. This is a scanning electron micrograph of the underside of a specific tree, the C. obtusa. And this is why we get the name the Velcro ants, because the hook and the loop works together like a Velcro. So they use that to their advantage when ambushing prey. So what they'll do is they'll line up on the edge of the leaf, and as soon as the prey gets close, they grab it, and once they get a hold of it, it's not going anywhere. Which I have a quick video to demonstrate that very quickly. As you can see, they're lined up on the edge of the leaf. And this is the prey. So they send a few guys to kind of push it to the edge. Once on the edge, they get a hold of it, it's done. That butterfly, it's done for. But the story doesn't end there. What's even more interesting is that those guy lives in a mutualistic relation with a specific tree, the Cecropia obtusa. It was noticed that they had a high preference to establish on the street Further research showed that the Cecropia obtusa, in comparison to other leaves, the underside of their leaves had more pronounced loops and they were denser. This is in F right here is the underside of the Cecropia obtusa, and this is the underside and G of Cecropia palmata, and you see a vast difference as far as density and pronunciation in the loops. And it's even hypothesized that the Velcro ants and the Cecropia obtusa have co-evolved together. Now that's interesting, and for that reason, the Cecropia gets protection from the ants, and the tree provides them houses and food bodies. But those guys don't eat the food bodies because they eat other insects. They're not herbivores. And thank you. This is the end of our presentation.